All right, guys, welcome back. I have a video that I wanted to share with you guys. We have a 2008 Mercury Mountaineer Premier, which is a 4.6 liter, and this vehicle was purchased about a month ago. I'm sorry, 3 months ago, and it was purchased at a used car Nissan dealer lot. And the gentleman that owns it said that the truck, he bought it. It's got low mileage, nice, clean vehicle. He got a Carfax done on it. Nothing to talk about. A minor rear end hit some years ago, cosmetic, bumper damage and stuff. Nothing crazy. And he said the truck was great. He says until about a month ago or so, and it started acting up. And he was driving it, and as he was driving, he noticed that warning lamps came on the dash, tire pressure, ABS, I believe, some other stuff came on. It was kind of random from what he was saying, and he said that he noticed that when those lights were on, the chime for the reverse would not work. A couple, little things inside the truck, and then he also noticed the signals were not displaying when he would turn the signals on, even though they were working outside the truck. They wouldn't illuminate on the cluster. So he brought it back to the dealer he purchased it from, and they basically told him there's no warranty. This is typical. Of a used vehicle, they don't want to get involved with certain things, and I guess they felt it might be something expensive or whatever. They didn't want to do it, and the truck was, taken back from the dealer, and he went to his local shop who recommended us. They didn't want to get involved with it for whatever reason. So here it goes, right? So the reason I wanted to talk about this truck is because of strategy. I like to incorporate videos into the channel that have, something to do with a strategy when you're diagnosing something. It may help guys that are out there. I don't know. You know what I mean? I'm hoping so. This is how we all learn from each other. So the main thing, the first thing that I wanted to do with this truck is I wanted to scan test it. Okay, and I wanted to talk about that a second. When I say I scan test a vehicle, I'm talking about going in with manufacturer-specific information, a scan tool that's capable of manufacturer, info, not generic OBD2 where you're just scanning a, engine control module for generic codes, and you can't get anything else out of the truck or the car. So when I go in with what I did was I went in with the Autel, the Elite, and I scanned all the modules, and I recorded my codes. As you see, I had multiple codes in the modules. Okay, I had different codes in different modules. I had what's important. I'm going to actually stick to what's important. Okay, the instrument cluster was showing multiple codes. The two codes that I focused on is what I'm going to focus on with you guys, and the reason. The U0140-60 and the U1900-60 is what I focused on because they were both complaining about no communication with another module. That was verified through the scan tool. The smart junction box or the GEM module, whatever you want to call it, would not communicate on this truck. Before I did anything else, I decided to hook up a different scan tool because you can have this issue sometimes. Okay, not normally when you have codes complaining about it, but I like to cover all my bases. And for the extra 5 minutes it takes me to hook up another scan tool, I don't want to get burned by something silly. So I hook up my Bosch. I still have no comm with the smart junction box, which is fine at that point because I'm expecting this. I just want to verify it's not a scan tool issue, okay? At that point, my next step being that I have multiple modules complaining about a smart junction box, I want to pull a diagram on the CAN data lines, okay? So what I'm going to show you is, I'm going to turn you guys around here in a second. I'm just pulling this up. All right, this is the computer data line wiring diagram for this vehicle, okay? And if you notice here, I'm going to zoom in a little so you can see better. We have MS CAN, medium speed CAN, and then we also have high-speed CAN, okay? Two different color wires as you see here. This is high-speed CAN, white and blue. And if I go to medium speed and I click on it, it will highlight all of that circuit, okay? So you could see every module that that medium speed can goes to and from, right? So you've got HVAC, you've got audio control, you've got smart junction box. This is the one that we're going to focus on. The smart junction box right here is the one we're going to actually focus on, okay? Because that is where our problem lies. We're not getting communication with that module. So now if you look, our wire colors are violet and orange and gray and orange. And you see the pins, okay, in the connector, 2280D, and it is pins 15 and 16 on that connector. All right, so now that we've got that established, our next move is to figure out why we don't have communication. All right, so what I did first is I took my Power Probe OBD2 breakout box and I plugged that in to the OBD2 connector. I powered the car down, disconnected the battery, and what I wanted to do was I wanted to see, because on the diagram here that I was showing you, those two pins that come from the smart junction box, I wanted to know what two pins they are on my OBD2 connector. They're pins 3 and 11. That's the medium speed can. What I wanted to do was ohm them out, and I wanted to see what I have. My resistance value on this circuit should be 60 ohms if everything is working properly. I don't want to get into a long-winded explanation of CAN data and all of that stuff that it entails, okay? But very, very short and basic here, you have to have 60 ohms of resistance on the high-speed network and the low-speed, and the medium-speed network on this vehicle if everything is working properly. Showing 120 ohms means that one of the resistors, the terminating resistors in one of the modules, is not there. It's not in line. If you want more information on all of this stuff, there's some great articles in Motor about it. There's great information online about CAN data. You guys can research it. If you have any questions that I can answer, put them in the comments. I'll try to answer them as best I can. But there's a lot of information out there. It's not no secrets. So okay, at that point, we have 120 ohms. We know that one of the terminating resistors is not in this loop. The good thing about that is there's only two. All right, for the medium speed can. There's one in the smart junction box. There's one in the instrument cluster, which is the gateway module. Now, your high speed, not to get off track, but your high speed can also has two terminating resistors. One is going to be inside of the PCM, okay, and one is going to be inside of the instrument cluster. So the instrument cluster has two, all right, terminating resistors in it, one for each network. That's just a little tidbit if you don't know. I'm sure most of you guys do. But now to get back on track, we know that we have 120 ohms of resistance in this circuit. We have to figure out why. Being that I have communication with the instrument cluster. The complaint is for the smart junction box. So I'm not going to bother wasting my time doing any testing at the instrument cluster, hopefully that makes sense. I'm going to the connector 2280D on my smart junction box. And when I do, I find something interesting. I find that the lock tab is broke, and I don't have a picture because my phone deleted it, and I really apologize for that. But the connector on this is sort of a European style locking connector, and it was broke. All right, so I was like, wow, it can't be that easy. This is awesome. It's always nice to see things when they're, simple like that, right? Because you're 10 minutes into the job at this point. So it's like, oh, this is great. Broken connector, lock, easy fix. So I pop it out, and it felt like it was in, you know what I mean? But it wasn't working. So I took it apart, took the connector off, and I checked it visibly. I checked the pins, retention, everything seemed okay. I used, for those guys that don't have one of these, I highly recommend buying a set from AES Wave. I'm going to put a link in the description as well of a test lead set that they sell. It's the absolute best one on the market, bar none, okay? If you don't believe me, go over to South Main Auto and ask Eric. He'll tell you the same thing, as well as about 100 other guys that I know personally that will vouch for this thing. This is an incredible kit, very, very, very much worth the money. So I find the right male pin that I need to test my connection, and I'm able to verify good pin retention on those data lines at the smart junction box. This is all just part of normal testing, obviously, that I want to make sure the pins are not spread or damaged. Wiring looks okay. Obviously, this has been tampered with because the lock is broke, but I don't care too much about that right now. What I do care about is seeing that I can restore this module to talk if the module is good. The fact that it was tampered with, I started thinking to myself, well, somebody was in here, they couldn't figure out what was wrong with it, or the smart junction box was verified bad. You know, the broken connection, you know, the lock on here being broke is just a byproduct of them working on it, and you know, that has a bad module, and whoever owned it traded it in because they didn't want to spend the money. You know, who knows, right? So we have to verify it anyway. We don't know for sure what it is, but I'm thinking right now we probably have a bad smart junction box. What I wanted to do before I went any further was I wanted to check, and I wanted to see what my resistance values were if I went from my OBD2 connector, my pins 3 and 11, which are my medium speed CAN. I'm going to go to one of those. I'm going to go to the corresponding pin on the junction box connector, and I'm going to ohm them out. So I went to one, and it was like 0.9 ohms. It's fine. The spec, if you guys are curious, okay, if you look up like service information on this, it'll tell you the spec is under 5 ohms or under is good. You're gonna see under an ohm, under an ohm, you're good. You know, that's where you're at. At that point, I went to the other lead, the other wire, which was my what color was that wire? Hang on a second. I think it was the other wire was the violet and orange. It was pin 15 that I went to. That was the second one. When I went to pin 15 on that connector, and my corresponding pin on the junction on the breakout box, I had this right here. That 15.82K ohms. It's no good. So I says, oh boy, this isn't a smart junction box issue, or well, it's not. If it is, it's not the only issue. So far we've come across a broken connector, and now we know for sure that we have a wiring issue from, you know, somewhere in this truck. And you just saw the diagram of where this medium speed CAN runs, okay, all over the place. So what's your next step? Well, for us, the logical next step was to go to something else that we can test, another point in the harness that we can test. Okay, so here's something else I want to just show you guys real fast here. That's kind of interesting. If I go to this diagram, and this is a Mitchell diagram, okay? This is a, you know, generic diagram, right? Rewritten. This is not factory, is what I'm getting at. I want to show you, if you follow these from the smart junction box, you'll see a splice point here and here, right, for these two different wires, okay? You'll see another splice point here and here for the same wires, okay? So this is where they all branch off, another splice point, right? Something you don't see, though, and I'm going to show you what I'm talking about. Hang tight. Okay, so I've gone out of that program, and I am going in now to my factory diagrams, okay? And I want to show you what I'm talking about. Right here, if you look, here is your smart junction box. Once again, sorry about that, guys. My filming has a lot to be desired. There's my smart junction box right here. Notice connector 2280D, pins 15 and 16, right? Now notice, what do we have here? Connector 214. That is not in the other diagram. There's your other splice points here, if you notice, right? There's your splice points, all the same splice points we saw, but we did not see this connector. So this is something to be aware of. Be very careful of this, okay? I'm gonna just pop out of there, and we're gonna show you connector 214. There it is. Notice near the glove box lamp, it is on the passenger side. There's the glove box right here. It's on the passenger side of the vehicle in the footwell, okay, kick panel. Why is this important? It's important because they don't give you this information in the other diagram. You don't know there's a connector there. So these are things that you need to be very aware of when you're diagnosing. And the reason I say that is because if you're not, you can easily miss a bad connection inside of a connector, corrosion, because you don't know the connector's there. So be really careful of that stuff, okay? It's just a little tidbit of info. Okay, so now that we got that straightened out and we are able to see what I'm talking about, the next step for me was to go to that connector, and what I wanted to do was I wanted to check, because that connector, that wire goes from my smart junction box across the dash and down into that connector. So I wanted to check that connector, and I wanted to make sure that I wasn't having an issue in there. It's an easy step, it's an easy thing to check, and it's good that I did, because, where is it? Over here, right over here. This is what we found when I took the sill plate off and I started taking the panel off. This is what we were looking at, and that harness was completely submerged in water. Guess what's in that harness? That harness is not all, but it is your data lines. They're included in there, and your splice points, which, if you look, this is underneath the seat. If you look at that seat bracket, all right, all of this is the back seat bracket now. This is all signs that we've had serious water intrusion in this car for a long time. I did stop right there, and I did go to my connector, 214, and I did disconnect it, and I did ohm it from the smart junction box connector down, just to verify that my integrity was there, which it was. I was happy with what I saw there, so I went back to my my door sill, where the harness runs, that was completely submerged in water. What I did was I pulled the harness out of the loom, and I started to check it, for any obvious damage, anything where, somebody may have pierced the wire, something, whatever, and the water got in and eroded it and it broke. Well, that wasn't the case. Nobody was in there. Nobody touched that. But I did find my splice joints, which you can see in the photo right up here somewhere, and of the video. And this was where I found my issue. I pulled on the harness, and the one wire snapped right off. It came apart. That is where you could see that there was all water damage from probably years of this going on. And at that point, we replaced the section of harness that I had to. I was able to cut it out and section in a good piece of wire, solder it, shrink tube, the whole 9 yards, insulated. And I had to drain the water out of this thing, obviously, so I drilled small holes in the sill plate, and I was able to drain it. And I tried to dry the truck as best I can, which is, without pulling the rugs up and getting everything out and the seats, and with the corrosion in here, I really didn't want to start dealing with breaking bolts and all kinds of other things. So I spoke to the customer. He came, and I actually brought him down to look at the truck, to show him what we found. He was ecstatic, because he really loves the truck and he really wants it fixed. And I mean, he wasn't happy about water being in it, but he was very happy that we found the problem. And I was even able to verify and make him happy by finding the water intrusion problem was the drains under the cowl and in the fender being clogged with debris. And I think I've showed that in another video on an Explorer going back some time ago. So people do not clean the debris that comes into the cowl, the leaves and the dirt and all the stuff. And what happens is that they blame the vehicle. It's not the vehicle's fault. That stuff all gets pulled down into the drains, and it just cakes up and clogs up, and the water's going to go somewhere. It's going to go in the truck. I cleared the drains for him. I've restored the wiring to integrity, and once that was finished, when I checked my resistance value, I had 60 ohms of resistance across 3 and 11. At that point, I reconnected the battery. I started the truck. I verified the lights were no longer on the dash. I had communication with my smart junction box, gem module, whatever you want to call it again. And the signals were restored. Everything was working properly. The truck still had an airbag light on. It does have another issue, which he's not concerned with at this point. He may fix it later. It also has codes for, it had a code for a compass module, no-com. That I was curious about more than anything else, so I just decided to look into it. It was pretty simple. I looked up at the rearview mirror to test the connector, or do my test at the connector, and the connector was hanging there with no compass module, so pretty simple diag on that one. The compass module was missing from the vehicle. At that point, I put the car back together for the gentleman, verified that my communication codes were all gone from all the other modules, and everybody's happy. The reason I'm doing this video is because I thought it was interesting, okay? You know, I always think it's interesting how you come to conclusion, how you follow a diag to conclusion. The hardest thing on this truck is access, and that's the truth. The body module on this truck is a royal pain in the ass, and that's absolutely the truth, because the emergency brake assembly is in the way. Nothing comes apart easy. You know, you're kind of in an uncomfortable position. It's a lousy job as far as getting under there. At least for me, my back hurts a lot and whatever. But you know, it was a little bit of a pain in the ass accessing, and there's no slack on the plug that I had to get to, this 2280D connector. There's absolutely no slack. So that harness you cannot pull down to do any testing. You have to kind of lay under there and, you know, check your pins, and, you know, it's uncomfortable. So not a fun job in that regard, but I always think it's very interesting how we start with a diag, and we follow, you know, a lot of guys are calling it a funnel, which I think is really cool. I think Mr. Jim Morton is one of the guys that has said that for years. You know, you find the right funnel, and you go down that funnel for your diag. Don't go down the wrong one. This was, you know, we were on track. It was, you know, we checked it properly from the start to finish, is what I'm getting at. And this can easily, you know, go down a bad path if you don't know how to test and what you're, you know, to know what you're looking for. So before you start diagging anything, my recommendation is to learn the system as best you can. Get insight from guys that may already know the system better than you. I don't have any files of this, but just for reference, I did have a oscilloscope hooked up on here on my medium speed can, and I forgot to mention that earlier. You have the OBD2 breakout box hooked up, so I, of course, put my scope into the, you know, into the pins 3 and 11, and I wanted to just check the signal, and I did not expect to see a problem there. So you could have made a big mistake by putting a junction box in here and trying it, like a lot of times will happen. Guys will say, like, oh, it doesn't communicate with this module, throw the module at it, or check powers and grounds. And, you know, they would have done that, you know, check powers and grounds and then threw a module at it, it would have done nothing. In this case, the module was actually good. So I was very happy for the gentleman. I was able to fix it for him, you know, for a fair price. And, you know, he was thrilled. I was thrilled to get his car back. You know, he just bought the car. Now he could enjoy it. It worked out well. So my thing is always understand what you're working with and what the system wants to see. Not everything nowadays, you know, guys, is, you know, 12 volts and ground. It doesn't work that way. So you have to know what you're looking for. You know, that's really all I could say. You have to, if you're going to put the time into a diag, spend the time wisely and know the system, know the circuits. And if you don't know them, my advice would be to try to do research first. And if you have to reach out to a phone a friend or whatever you want to do, call somebody. Call somebody who's more experienced. You know what I mean? It's that's why this whole network thing is fantastic. If you run into something, you can call somebody and you can get some input. Luckily for us, we knew this system well enough where we didn't have to phone a friend. I didn't use a lifeline on this one, but the truck worked out great. And like I said, it's a happy customer, so that's what counts in the end for me. If you guys have any comments, questions, criticisms, whatever you guys want to call it, leave them in the comments. Like, share, subscribe, guys. I really, really appreciate the support. And you guys are helping this channel to grow. And, it wasn't long ago I had 1,000 subs, and we're up to, just over 11,000 now. I'd love to see 20,000. Really appreciate it. Thanks for all the comments. Thanks for all the feedback. Thanks for reaching out to me during this pandemic that we got going on and this craziness. I really appreciate that. So I try to, like I said, I try to give out good information best I can with what I have to work with. It's just that lately it's been hard for me to try to film some of this stuff while I'm doing it. So I'm getting little tidbits and I'm trying to fill in the blanks with you guys after the fact. I hope that's okay. We do have something else that I'm going to be starting on too, and I'll actually take you out and show you. All right, so this is our this is a steering column, obviously, electric, as you can see, and it's made by a company called ePass. So this is the first one I've ever done. It's going into this 65 Mustang here. I started getting the components together and just starting to plan out what we got to do. It's going to be a project. I was thinking about filming some of this. If anybody's interested, I don't know. I don't want to waste my time if there's no interest in it. We started to take the column apart. Nothing really to see so far. But if you guys are interested in seeing it, leave it in the comments and maybe we'll film it. All right, guys. That's pretty much it for now. Thanks for watching, and I'll see you soon.